Um, now, well, I mean, most of us are here because we find big data, the area in computing, fascinating. And in the coming years, I'm sure every human endeavor will be impacted by it. Um, well, are there any audio issues? Well, before we go on, I think well, just a second. Let me make sure we are able to handle the audio correctly. If you have to mute yourself, or if you are on mute, if you have to speak, you can unmute by pressing *6. So that's just some info that might be handy. Now, going back to what I was saying, it's the big data area. It's interdisciplinary, and it's quite fascinating. By if you look at the number of domains that can use it, and the number of areas where it actually gets its methods and algorithms. Now,
sorry, Kumar, can you speak a little bit loudly?
Okay, yeah. So I mean, the cool aspect of big data technologies is that most of these are open source, and if you have time and and energies, you can dig in. And thanks for joining this meetup. So in this session today, I don't have much to present, other than throwing open a question as to what we can do as a group. This session today is basically to initiate a big data activity, and I hope this will lead to something significant. Now, as I mentioned in the agenda, agenda on the meetup on the meetup site for this meeting, what we want to discuss today are these physical meetings versus virtual meetings. I think we should have a mix of this, but I would like to hear your views as well. And the other thing that we want to talk about is big data practice. As you know, it comprises of a very vast landscape of technologies and methods. As a group, where do we start? I mean, if we are a large group, a lot of people get active on this, we can get started on a lot of things, but we have to coordinate, meet, and then get started on as many activities as we can. And some other suggestions. This was Preeta's suggestions as well. That we should start on a Kaggle problem. And again, Kaggle has a lot of data sets and a lot of data problems, data analysis problems. Which one would we pick? And most of what we do in terms of algorithms would involve mathematics of some kind, and we can explore the mathematics behind it as well. Again, where do we start? So these are the questions I just would like to talk about. If you have ideas or preferences, please express those. Now, physical meetings versus virtual meetings. Let's talk about that. For physical meetings, we did quite a number of physical meetings in the past. We used to meet at one of the community centers in Mississauga. Now, we could actually get a sponsor who could actually sponsor a venue and things like that. But somebody has to actively go for seeking the sponsorships, and I basically don't have time or connections for this. So the easiest for me would basically be to book a community center, and the limitation there is that it costs about $60 to $70 for every 2 hours, and I can book some, but if we had to meet frequently, we'll have to pull in. So if we are 15 or 20 people, it costs about $5 per meeting or so. So that's the kind of cost we're talking about. I can do like 3 or 4 per year, on out of my pocket. And virtual meetings, of course, there's no limit. I basically have the subscriptions for JoinMe, and we can use that, and there is no limit as to how much we can use.
Preeta here.
Go ahead, Preeta.
So, how about having something like, if a virtual meeting is not cost, it's not going to incur cost on you, then maybe more frequent meetings would be on virtual, and maybe if we can plan in advance and get RSVP for physical meeting, and then plan for, booking the places may work. Yeah.
Yeah, I mean, actually, that's the thing I was thinking about as well. Now, it's easy, like I can just book a meeting, and then when people come in, we can just make it optional. If they just drop a few dollars in a box, that will take care of the expenses. If we collect a few more dollars, we can just get some refreshments as well. Exactly. That's exactly what I'm thinking also. So, I mean, on my part, I can just go with 3 or 4, and if people contribute, we can maybe make one a month or so. So that's one physical meetings, and virtual meetings we can do more. It depends on what kind of activity we get started with. Like who wants to present. If there are many people who would want to present, we will have more of these meetings. So, and the other thing is, should we start working on a Kaggle problem? It looks like at least some of us would like to. I would like to, actually, and I know there is some interest in the group. Preeta mentioned as well. So if anybody else is enthusiastic about a Kaggle problem, just express your interest, and we can get together on one of the Kaggle problems and get started. So does anybody else have any preference on what we should be doing, like Kaggle or something else?
Well, I'll jump in. So I'm Jay Michaela. I'm out in Waterloo, and I'm not a mathematician. I have done data analysis, but it tends more to be, let's say, more conventional, statistical, multiple regression, that kind of thing. Mm-hmm. And I'm very interested because I'm a professor in psychology and related areas of management and so on, I'm really interested in what people are doing with big data, and in the sense of why are they doing it in the first place? What contributions is it making to business or making a better world or whatever else? So I could learn from this group about mathematics and so on, a different kind of math and stats than what I do. But I have a special interest in making the most of whatever the methods might be in terms of the ultimate purposes. So anyway, that's that's my primary interest.
Well, that's actually great, and I'm sure you'll have a lot to share as well as after you find something interesting. You probably have a lot of interesting things to share already about big data. And anything else that you'd want to share with the group, that would be wonderful.
Well, let's see. In terms of sharing, I've had a few experiences in the past of integrating different categories of data. So I guess in business terms, my area of application is human resource management, and so some of what I've done has been, let's say, fairly straightforward, of integrating data of different kinds at different levels of aggregation, individual employees and units and so on, and sometimes the actual analysis has been of some complexity, like something called multi-level modeling, which is starts with multiple regression, but goes beyond that into taking account of different levels of analysis. So yeah, conceivably we could talk about some of that, but I honestly don't feel that those technical aspects are my strength. I have a different take than probably a lot of the people here, and for the technical parts that I'm good at, it's pretty good. But like I said, it's more fitting the different pieces together of why are we doing it and how to make a contribution with it that I'm hoping some people will have an eye on, and that'll be a basis of connecting.
Sure. Yeah. In fact, this is the nature of big data projects. You will have people from many backgrounds, not just one. Some are good at just understanding what the data is, and some are good at the algorithms that can be run on the data, mm-hmm. and others on implementation. So it's the nature of a big data project is highly interdisciplinary, mm-hmm. and that's where we usually need a group of people to actually span a set of activities on big data. So it fits into the scheme of things. What you're looking for is actually something realistic in a big data project like this.
Mm-hmm. Good. Well, I'm glad to hear that.
And so let's move ahead. So at end of today, hopefully we will have some plan for what we will do next. Okay. Well, let me actually walk you through the objectives of this group. When I started this group a couple of years ago, this is what I had in mind, and not much has changed. And we did make some progress on certain, in certain areas as well. Now the objective is actually to do a deep dive into data analysis algorithms, and well, when you talk about data analysis algorithms, you're talking about a very wide set of methods, and there's a lot of variety, in terms of mathematics that goes in terms of the statistical methods that go in and things like that. And it's very difficult to get a grasp of all of it, but for a given project, you don't need a whole span of these. So I mean, when you start with a data set, you just start with what's relevant with that, and then start learning things along the way. That usually is the method that I see working for me as well. This is something that we can do, as a group. Now, understanding the algorithms that can be applied on data, a deep dive into the algorithms, that's one thing. The other thing that we can look at is develop code to actually implement all the phases of a typical big data project. Now, when you get started with a project, you probably have a data set that's not ideal to run algorithms on. You basically have data, so the data has to be brought into where you want to analyze it. So if it is a really large data, that itself is a task that needs different technologies and things like that. You could be talking about data coming in structured form or unstructured. You could be talking about data streaming in, like Twitter streams, for example. That's one thing. And handling data ingestion into your cluster, if you're looking at a big data project, that itself will need a lot of methods and a lot of expertise. And then you need to eventually get the data into a form where you can run an algorithm on. And, that means you have to clean up a lot of stuff. You have to transform your data into what is suitable for running an algorithm. Now, that's one part, and all of that needs coding. And eventually, when the data is already in a form that can be consumed by an algorithm, running analytics on such data is the next step. And if you know what to run, that will be turning that into code is a simple part compared to the other things like ingestion. What we hear most of the time, and what we see, is that about 70 to 80% of the effort goes in transforming the data into a form that's needed for analytics. And once you run it, let me just mention that running analytics on data sometimes needs if it is large data, you basically will need a cluster, and then you have different programming paradigms. Things like Spark SQL. If some of you are familiar with that, that's what is needed there. And then once you run analytics on that and have results in some format, how do you visualize that? That's another set of technologies there. Now, to actually have a realistic project going, we will be interfacing with a lot of technologies. So you have data analysis algorithms on one side, and then you have the technologies that needs to be mastered on the other side. Now, to get something going, in a meetup like this, if you're looking at anything more than just presenting a topic or presenting an algorithm, if you would like to get into doing a project, it needs more commitment than just preparing for a presentation or just explaining an algorithm. So this is where I was looking for people who can get involved in the learning process, right? So so with this, I think we would at least need at least one physical meetup a month and a few virtual sessions. If we get into a project mode. So in between, one can just work independently and then develop modules and stuff like that. So this is what we would be looking for in the meetup. Now, okay. In the earlier meetups, just to give a perspective of what we did, and well, this is not ideal though. We could have done better. So hopefully we'll do better going forward. So what we did was this: like we basically have people present algorithms. So some of the presentations in this group were on regression methods, clustering algorithms, the usual stuff, the k-means, hierarchical clustering, and things like that. What one can do with data, applying these algorithms on it, and principal component analysis. Those were the algorithms that were discussed. And we did have quite a number of sessions on HDFS and MapReduce, Spark, and we did a small project on text processing. So this project was actually to start with a set of documents, and the document set that we looked at had about 7.5 million entries. Now the idea is to run an algorithm that will just find pairs of documents that are similar, and the criteria for similarity was a part of this processing. So you change what similarity is, and you get a different set and things like that. So the idea is actually to work through the algorithm and implement it. It was implemented in Java, and if you go to the URL that's on this slide, this is actually a blog that I have, and the code is actually on GitHub at this location. So if somebody is interested, they can take a look and see if you can suggest any improvements. So this is what we.
Excuse me.
Sure.
The slide that I'm seeing just has the participant keypad commands. Should I do a refresh or something?
I think you should refresh. Yeah.
Okay.
Yeah, you should see earlier meetings. Do you see that? I don't know what's going on. It looks like
okay. Yes, earlier meetings. Yes. No,
yeah.
it's my fault. My fault. Yes. Thank you.
Okay. So at the bottom of the slide, you see two URLs. So well, this is Java code. One could write Scala or Python to do the same thing. This is implemented on Spark, so using Spark API, and we could think of various modifications of this. Instead of a static data set, we could have this algorithm run on streaming data. That's a modification we can do. There are a lot of things that we can do with just this as a starting point.
Kumar, Preeta here. In your blog, do you have the link to GitHub?
Yes. Yeah.
Okay.
Yeah.
Thanks.
Yeah. The link to blog is all you need.
Okay.
Okay. So hopefully we will be able to do something similar going forward. So if you refresh your screen, I just got to another screen. So this is just to give you an idea, for those who are not familiar with all the concepts, all the modules, all the components of a big data stack. Here is what you basically have. The popular languages are Scala, Python, and Java and R is there. R is actually catching up. And well, I just mentioned these tools. One would be working with these tools: Maven, Gradle, SBT, Git. I'm just throwing these names here. Let's not go into what each of these things do. On the Hadoop stack, when you say Hadoop stack, you're actually talking about a bunch of big data components packaged by one of the distributors, like how you have Red Hat Linux and those things. Hadoop stack is also packaged, and the popular vendors are Hortonworks. You have Cloudera and you have MapR. So just to go through this, HDFS is basically just the file system, the distributed file system, and Yarn gives you. I'm trying to find my cursor. So, Yarn that you see on the left-hand side of the rectangle there, is just a resource manager application that works on a cluster, and Spark is the de facto programming model that you have. Earlier, it used to be MapReduce, and most of the current projects use Spark. And you have when you have a cluster, usually it's multi-tenant in an enterprise. Like you will have a large cluster, and multiple teams would make use of it, and that brings in a lot of security issues. You will have issues such as who gets access to what, and how do you authenticate users, and how do you protect data. You may have confidential data on your cluster and things like that. So you have a range of tools. Not all of them are as mature as they should be, but people are working with these right now. Those are the names of the modules involved. And then you have search engines, and then you have to work with data. You could do SQL kind of things on data on the cluster. So you use those, and you have workflows and stuff like that. So it's like I'm just mentioning these just to tell you that it's a vast landscape, and where do we start? That's the question. I'd like to ask. If we should be doing some project. Now, as to the methods, the algorithms, you basically have a large set of methods that are used on data. I just mentioned a few, the names that I'm familiar with. And then you also have mathematics coming in. There are new fancy methods methods from topology, for example, introduced into data analysis, and that gives some new insights into data, and algebraic geometry, for example. And things like PCA, linear algebra is heavily involved, and you have graph theory. You have a lot of graph algorithms and things like that. So, well, the methods applied from these may not be very abstract and things like that, but then well, these are things one has to learn to get a feel for what goes on in the algorithms. And then you have a set of data visualization technologies. Now, I didn't mention any of these. I'm not very familiar with the data visualization technologies other than just some names. So I just left this. So this is another piece of the landscape that we can look at. Now, there are other technologies as well that can get involved when you're working on a big data cluster. Cloud computing, for example. So OpenStack is basically an open source platform which you could use to implement cloud. And Amazon, Azure, and these are popular cloud services. And one could look at like when you have a cluster, you can compartmentalize your application by things such as Docker and things like that. One could spend time on these. These will be interesting topics also to discuss. And Kerberos is more about security. This technology developed by MIT gets involved in most of Hadoop projects these days. Mesos is another distributed, one could call it distributed OS, similar to Yarn. On a cluster, you could run a set of, you could run your Spark algorithms on Mesos. And Linux cgroups is something that's, cgroups is something that's associated with how you compartmentalize virtual machines in a cluster. So, well, all of these are extremely interesting topics. They are all changing rapidly, and any of these topics would be game for our meetup. Now, if we had to go with Kaggle, like where do we start? This is a question I'd like to ask. And something that we can do is, if we have more than just a few people interested, we could make multiple teams, and we could work on different aspects of the same project, or we could just have different projects going. So the idea is do your projects independently and meet somewhere and discuss. So that way, we exchange a lot of ideas and we learn. So that's the idea. Now, this is basically an invitation for everyone on this session. So if you have a presentation that you would like to make, please feel free to just present it. It doesn't have to be complete. It doesn't have to be rigorous in every form. Just get started. Keep talking, and the ideas. Any idea in big data is really fascinating, and one could get started and then just getting started with a topic, we can kick off a discussion and learn from each other. And collaboration on Kaggle problems, this is something that we can do to further our learning. And so basically, that's all I have in terms of what I'd like to show. I think we have another 15 minutes or so. We can talk about what you think we should do.
Kumar Preeta here. Regarding, I think most of us in this meeting are new. I think I'm not sure about others, but I'm assuming that we have not done any real-time projects yet in big data. So, maybe a couple of initial meetings, we can pick a common topic and share the work among ourselves. Maybe someone will do data analysis and a group will do. I don't know if we have so many, such a big team. Based on that, we can divide the work and do something. Maybe pick a topic from Kaggle for beginning. Okay. Yeah. So gradually, we should pick some real-time big data, maybe for a weather forecast or something related to health, wherein we can give something back to the society, wherein we do something real on a real-time project, learn from Kaggle and apply that. Yeah, so that's where I'm coming from. Learn something and use the existing open data and give something back to the society as a group. Prediction or weather is a good area.
Yeah. I mean, like we need to. I think we need to understand. What we can do, right? I mean, so at a high level, I agree. So we had to get into details as to where do we start, which data set we would pick up, and things like that. So if you could spend some time on Kaggle and identify a data set, and we can get started. Like when I was looking at it, I was thinking about. There is quite a lot of data sets where, they look at sentiment analysis.
Right.
This is an area in text processing where, very interesting methods of text processing, get in. One of them, is actually, clustering documents. So, when I say documents, a tweet could be a document in this case. And there are things like NLP, like natural language processing and things like that. A lot of interesting areas. But, when we get started on this, we have to take it to some logical conclusion, and that would need, people to commit their time on this. So this is where, we basically have about, at any given time, there'll be 10 or 15 people who would be interested. But eventually, if we meet more often, I think that number will probably grow. What you say is right. We could just get started with a data set, and take the project to a logical conclusion. Yeah. So any other comments from anyone?
Kumar, this is Murli. Just one suggestion. So, this is Murli.
Murli, okay.
So I was just going to say, like for the next meetup, before the next meetup, why don't we look at some of the data problems and see what we can work towards?
Sure. Yeah.
Maybe if different people pick up different ideas, and then probably we can discuss, and as a group we can start working on one with different ideas of how we can use those data sets or what we can do to solve those problems.
Sure. Well, I can surely look for one, and that's from my side.
Like
So if you find something, just flash a message on to the group.
Yep.
Hi, Kumar. This is Sridhar.
Hey, Sridhar.
Hi. One thing. So what you presented is good until now. What I'm thinking, so do we have any environment to do this implementation? First, obviously, we have to nail down what we are doing, like which use case we are tackling, or which as whether it's firstly a domain, and then which sort of, whether it's a sentiment analysis and all. So that's one thing, and to determine who the final user will be, right? So then we can tune our analysis in such a way. Second, which environment are we going to do? Because if you are going to use the Spark and other technologies that you showed there, like, do we have a dedicated sort of a small cluster environment anywhere?
It's easy to set up. I have one cluster already on Amazon. We could use that, expand it if needed.
Okay, even a small one, because obviously we don't want a huge data, because that costs something on whether it is Amazon or some other thing, right? So and from
go ahead. Yeah, I'm sorry.
So what I'm saying, Kaggle and all, I think the data sets themselves are small, right?
Data sets are small. Not
which is
all
good.
Data sets are small. Some of them are small for a cluster, but they are large enough if you want to just run it on your laptop. Yeah.
No. I mean, I'm not saying this is an impediment. In fact, that might be good for a startup for us. Starting off, because it doesn't demand a huge cluster to be made in Amazon or something, because then again, costing of that and things come into play. Okay, so if something is already set up, that is one thing. Then we have to determine, so you mentioned Java, right? Typically people are doing it on Scala, some of the Spark use cases, right? So.
Well, Scala is ideal actually for Spark. So I mean, if I do the next one, it will not be Java, it will be Scala.
Right. I think we have to go into that direction, and obviously some R packages, I think I'm not completely familiar, but some are not being supported R package in Scala. But I mean, we can further dig into this, because again, Spark itself is evolving, and it's not a mature thing as of now, right? So.
Yeah, if you look at Spark, the Scala libraries for Spark are current. They're up to date.
Okay.
And well, almost up to date, because the Scala language version itself is a few versions ahead of what is used in Spark. But Java is of course up to date, because Java and Scala go hand in hand. Both are JVM languages. Now, if you look at R or Python, they lag behind a little bit, but not much. For our purposes, it doesn't matter. We can go with Python or Spark or Scala. But with Python, the good thing is, there are tools like, I don't know if you have come across IPython notebooks. You could put your data set somewhere and then run your notebooks. So in a very interactive way, you can analyze your data. So there are a lot of possibilities with Python. Python is something that's hard to ignore. So Scala and Python is what I think would be best.
Yeah, we could go with Scala, because it's written in Scala, I think. So either way, we can discuss that. Each one will have its own opinion. Only thing I'm not sure whether all the libraries within a standard are like DPLYR and that kind of thing, right? For doing the visualization stuff and all. I'm not sure if Spark supports them as of now. I don't know that.
For visualization, you don't have to directly go with Spark. I mean, Spark is used to process your data, and then the output is saved somewhere, usually on HDFS. So for your visualization, you will either go to HDFS or a local file system where the results are moved to. So
yeah. Okay, I mean, we'll explore that because I'm not sure because primarily most of them are like, R is the number one on the data science part of this tasks, right? So how much the Spark is putting that?
Yeah. Well, Spark implementation in R, you can actually run your Spark programs by coding your algorithms in R. It's possible.
Okay.
I mean, like it has an R interface as well. Like it has a Python interface as it has for Scala. So well, these are the 4 languages that you can use, like 4 or 5, like Java, Scala, Python.
Yeah. Okay. So that's fine. So I mean, we have to take it one by one, I guess. So first thing first is to determine what use case we are attacking. To sort of see who is the final consumer of this, or at least consumer means we are not targeting anyone, but like we need to have some target for ourselves to sort of start off this exercise and see what we are determining or what we are predicting.
Yeah.
So that kind of thing. So from there we can start off.
Sure. Yeah. So I mean the plan. Yeah. So please go ahead. Yeah.
Jay here. I just wanted to ask. So in terms of languages, so I program, but I don't program in very many languages or at that high a level. Is there a trade-off of kind of power versus generality for the languages you've been talking about? So I'm imagining that maybe Python would be very general because it has interfaces to all kinds of things, but the other tools you're talking about maybe are more focused and better suited to certain types of functions?
I think, yeah. Well, Scala would probably be a little faster, but it's just just an incremental difference. It's not a lot. But the way your big data applications work, if something is slow, if you want to make things run faster, you just chop it up into more pieces and then distribute it on a larger cluster. That's what you do. So, and these things are commodity machines. So if something is running slow, if you'd want to run it a little faster, you just would add a few more nodes to your cluster and then do a redistribution.
Right.
So and they are not very different in terms of, I mean, if Python is 98% efficient, Python performs at 98% level of what Scala performs, you're still okay. So, I mean, we're looking at a difference of that kind, I guess. And the conveniences that you get of using one against the other, they're pretty significant.
Well, I'm wondering specifically about Python, whether the convenience is that it does most things, and so it could be seen as the hub with other things more the specialized. But I don't know the other ones you're talking about.
Yeah. Yeah. Well, Python is easy as well. You can Python and Scala are both. Scala can get difficult if you resort to purely functional style programming. But in terms of ease of usage, both can work on. Both can be interactive. You can run your Scala commands interactively, like how you do on Python.
Mm-hmm.
So, for example, if you have a data set stored somewhere on HDFS, you could actually run a PySpark program where on one line you say just initiate my Spark context, and it just makes the right connections to the cluster,
Okay, so why would you not do that?
Well, you could do that in Python. You could do that in Scala as well.
Okay.
And the beauty of Scala is you could leverage a lot of Java libraries that are already there. And so when you're writing your Scala program, you could just import your Java classes right into it.
Okay.
And Python is not lagging behind as well. Python has a ton of libraries as well. So, well, I think it all depends on what you're familiar with. I mean, if your background, if you have spent a lot of time in Python, I think you just have to go with Python. And if you like functional style of programming, Scala is the thing. So I think we should wind up. But before that, I was thinking, this should be our plan. I mean, I will be away for the next 25 days. I'm back on May 20th, and I can arrange for a physical meetup in Mississauga right after that. I think between, let's say, 25th and 30th of May, we can just meet and talk about a project. So meanwhile, we have about a month's time. And with emails and through the website, we can interact. We can exchange ideas. Until then, we can take some time and just go through the data sets and the data algorithms that we would want to work on and things like that. And by end of May, if we have a concrete formulation of a problem, that would be great. And we should be able to think of a project that should be done in 3 to 4 months. So that should be the plan. So it could be one project or multiple. If we have more people with more ideas, we should be able to run parallelly on all of them, ideally. So yeah. I mean, you can look forward to a physical meeting in the end of May, and we can have more of these virtual meetings after. So on the website, I'll just send out details as to how we could interact. I mean, on the meetup page for this meetup, we can keep adding comments. That's one way we can exchange any ideas we may have on this. So I guess, yeah, it was a good meeting. I think hopefully we'll do something significant in the group.
So, Kumar, you mean to say we'll decide on the project in the coming days, right? Through email communication or through meetup?
Yeah. End of May, we'll meet and so by end of May, you should have a concrete formalization of a problem.
Okay.
And a project. Yeah. So that's the idea. Let's work towards that.
Okay. Sounds good.
Okay. Thanks, everyone. Good night.
Good night.
Thanks for your
Good
time.
night. Thanks.
Kumar. Thank you.
Thank you. Bye.
Thanks, Kumar. Bye.
Thanks. Bye.
Thank you.